Welcome back to our RPG tutorial series. In this episode, our enemy is finally going to do a little more than just exist. We will add an idle mode and a chase mode, along with damage for both the player and the enemy, plus a health display to make everything feel much more like a real game. And of course, I also have a few extra little additions for you, so stay tuned. Let's get started. So far, we've built a small world with 2 maps. Our enemy is placed, we can switch between scenes, but our evil little enemy here doesn't react to us at all. And before we build a combat system for the player, we want to make sure the enemy can actually fight back. I mean, attacking a helpless slime isn't very exciting. So let's fix that. Our enemy needs an aggro range. For this we add an area 2D, and inside it, a collision shape 2D. We'll use a circle shape and scale it up a bit. This defines the area in which the enemy will detect and attack the player. If we save the scene and jump back into our world, we can already see how large this area is compared to the map. Let's start with this size for now and see how it feels. Now, for the enemy to detect us inside this zone, we need to use signals again. We already used them for switching scenes, and it works exactly the same way here. So we use the body entered signal, but before connecting it, let's rename our area 2D to detection area. That way, it's much easier to identify later. Now we connect the signals, we use body entered, and this time also body exited, so the enemy can start chasing us when we enter the area and stop again when we move too far away. To make this work, we'll need a few variables. First, we define a speed. Let's set it to 50. Then we create a variable called player chase, which is set to false by default. This will later be switched to true by our signal. And finally, we define a player variable, which is currently null. Now let's use that variable. Inside the body entered signal, we assign the body to our player variable. So the moment the player enters the detection area, they get stored here. That means we can now access the player's position directly through this variable. We do the same in the body exited signal, but here we reset the player back to null. And of course, we need to remove the var here. Otherwise the system would think we're creating a new variable, but that's not what we want. We're updating the existing one. And we update our player chase variable as well. When entering the variable becomes true, when exiting the variable becomes false. Now let's move into physics process. This is where the logic begins. We check if player chase is true. You might see it written like this, but we can simplify it. Just write, if player chase, it means exactly the same thing. And if we wanted the opposite, we'd write, if not player chase. This keeps the code cleaner and easier to read. Alright, to make the enemy chase the player, we need some logic based on player chase. But before we implement the actual movement, let me show you a really useful way to test your code. We can use the print function. This allows us to see what's happening in the output. So if player chase is active, we print something like chasing. Otherwise we print idle. This way we can verify our logic before adding any real functionality. And here's another small mistake I missed. Let's test it. And right away, we can see something's off. Player chase is already active at the start, which shouldn't happen. But when we leave the aggro zone, it switches to idle. And when we enter again, back to chasing. So the logic kind of works, but it's being triggered too early. Let's fix that. First, inside ready, we explicitly set player chase to false. This ensures a clean starting state. But the real issue is this. The enemy is detecting itself inside its own detection area. So we need to check if the detected body is actually the player. We add this check in both signals. Now let's test again. Much better. Idle. Enter the aggro zone. Chasing. Leave. Idle. Enter again. Chasing. Perfect. Now that our logic works, we can keep these checks in place and move on to the actual movement. Inside physics process, we use the enemy's position and move it toward the player. So we calculate the direction from the enemy to the player and apply movement in that direction. Don't forget to call move and slide so collisions are handled properly. Let's test it. And there we go. Our little enemy is now chasing us. This is a very simple one-liner approach to create a basic chase behavior. We'll improve and refine this later on, but for now, this is more than enough to move forward with our combat system. So far, our enemy only has a single animation, idle. In this part of the tutorial, we'll add another one, walk side. This will make the enemy movement look a lot nicer. For now, that's all we really need. Just like before, we create a new animation and assign the correct sprites. We'll use this row here for the side movement, 6 frames. And this is how it looks when the enemy walks. Now, let's plug this animation directly into our movement logic. For this simple chase behavior, we can just play the walk side animation, but we also want the enemy to face the correct direction. So we check whether the enemy is to the left or right of the player. We do this by comparing their positions. If the result is less than 0, we flip the sprite. Otherwise, if the value is positive, we set flip H to false. This way, the enemy always turns toward the player while chasing. And finally, if player chase is not active, we switch back to the idle animation. Let's test it. And there we go. Already looks much better. The enemy turns correctly, moves in the right direction, and switches back to idle when the chase ends. Nice. Now that the enemy can chase us, let's move on to player damage. For that, we need a hitbox. So we add an area 2D with a collision shape 2D. Because we want to detect when the enemy is close enough to deal damage. We'll use a circle shape again and give it a reasonable size. So whenever the enemy enters this area, the player will start taking damage. And not just once, but continuously over time, as long as the enemy stays within range. This is a very simple way to implement enemy attacks. Let's rename this area to player hitbox. Now, to actually see the damage, we'll add a progress bar to the player, place it correctly in the scene tree and rename it to health bar. To make it look cleaner, we disable show percentage and scale it down so it fits nicely under the player. After saving the scene, we can already see it in the world. Still a bit too large. let's shrink it a little more. That looks much better. Alright, so where do we start? Of course, with variables. We'll need a few new ones here. First, a variable to check if the enemy is close enough to deal damage. Second, a variable to track whether enough time has passed between attacks. Then, we need a health variable for the player. And another one to check if the player is still alive. Next, we go to our player hitbox and connect the signals for body entered and body exited. Now, just like we did before with the player, we also need a simple identifier for the enemy. So in the enemy script, we create an empty function called enemy. This allows us to check whether the detected body is actually an enemy. Now, inside our signals, we do the following. If the body has the method enemy, we set our attack range variable to true when entering and back to false when exiting. And with that, we can now detect when an enemy is close enough to deal damage. Alright, next we create a function called enemy attack. As the name suggests, this function will handle damage to the player. For now, we'll keep it very simple. If the enemy is close enough, we reduce the player's health by 20. So with 100 health, that gives us about 5 hits. Next, we create another function, update health. This one updates the health bar. We assign the health bar to a variable, and to control what it displays, we use its value property. We simply set it equal to our player health variable. Now, let's add a small improvement. If the player's health is at 100, so full health, we hide the health bar. Otherwise, as soon as the player takes damage, it becomes visible. This way we don't always have a bar under the player. We can also give it a bit of styling. Let's make it green and maybe add a bit of transparency. Now, important step. We need to call both functions inside physics process. Otherwise, nothing will happen. Let's test it. We move close to the enemy, and boom, the entire health bar is gone instantly. What's happening? Well, we're dealing damage every single frame, so the player drops to 0 almost immediately. Let's fix that. And for this we use our attack cooldown variable. We add it here inside our enemy attack function. So after each hit, we set attack cooldown to false. And for the attack to happen, this variable needs to be true. So if attack cooldown is true, the player takes 20 damage, and then the variable is set to false again until we reset it later. This way, the attack only triggers once until we manually allow it again. But of course we want repeated damage over time. So we add a timer node, and once again I placed this node in the wrong spot. That's what happens when the wrong node is selected. And let's rename the timer to something like cooldown. Now, when the cooldown is false, we start the timer. And when the timer finishes, we use its timeout signal to reset the cooldown back to true. That means, if the enemy is still in range, the next attack will trigger again. One more important detail. When the timer finishes, we stop it. Otherwise it would keep looping endlessly. By default, the timer is set to 1 second. We'll reduce that to 0.5 seconds. And also lower the damage to 10. Alright, let's test again. We move close to the enemy, and now you can see the health bar slowly ticking down. Much better. Now, nothing really happens yet when the player's health reaches 0. So let's quickly implement a basic death system. If the player's health is less than or equal to 0, we set player alive to false. We also clamp the health to 0, so it doesn't go into negative values. And for now, we'll just print a message. Then we add one more important line: self queue free. This simply removes the player node from the scene, so once the player dies, they're gone. Let's test it. Health drops to 0, and gone. Now, you might notice we don't actually see our print message. That's because these other print statements are constantly overriding it. Quick tip, you can use a hashtag, like this, to comment out code. That way it won't be executed. This is useful for nodes, explanations, or temporarily disabling code. Alright, back to the player. Now it's time to add our attack. Time to get some revenge. Alright, let me clean things up a bit first. I'll collapse the functions we don't need right now. We create a new function called attack. And don't forget to call it inside physics process. Now, what do we need? We'll use current direction to determine which animation to play. And we check for input using isActionPressed. We'll use an action called attack, but this input doesn't exist yet, so let's create it. Go into the project settings, and here you can define your own inputs. We could use something like UI accept with the space key, but instead, let's create a custom one. Add the new action called attack, and assign it a key, for example space. Just press the key and it gets detected automatically. Now we're ready to use it. Next, we create a variable called attack_IP. We'll use this to control the animation and distinguish between movement and attacking. And we also add a global variable to detect attacks on the enemy side. Let's call it player current attack and set it to false. Now, inside our attack function, when the attack button is pressed, we set this global variable to true, so the enemy knows that it's being attacked. At the same time, we set attack IP to true, so we can control what happens to movement during the attack. And finally, based on the player's direction, right, left, up or down, we play the corresponding animation, and that's the foundation for our attack system. Alright, now we need to create the attack animations. We already have attack side, so let's add attack front and attack back as well. Assign the correct sprites. You already know the process by now. We also have matching sprites for the player's death. I'll skip those in this tutorial for now, but if you'd like, feel free to try implementing them yourself. And now we can play these animations. One important detail. For left and right, we still need to handle flip H. For up and down, we can simply leave it set to false. Now, looking at our animation, we have 4 frames and at 5 frames per second. That gives us a duration of about 0.8 seconds. So we'll create a timer for the attack and set it to 0.8 seconds. Each time an attack is triggered, we start this timer, and this will reset the necessary variables once the timer finishes. This way, we prevent a new attack from interrupting the current animation, and also make sure that other animations don't override our ongoing attack. For this, we use the timeout signal. Once it's triggered, we stop the timer and reset the necessary variables. And these are the variables. First, attack IP. We use this one to block the movement animations while attacking. And then we have the global variable player current attack. We'll use this later to apply damage to the enemy. Alright, let's test it. Okay, that was unexpected. Looks like we have an error inside our attack function. I can already see it. We're referencing a variable that doesn't even exist. This should be player current attack, not enemy current attack. Let's fix that. And test again. Alright, no more errors, but it's still not working. That usually means our attack animation is being overridden. And really, there's only one other animation that can override our attack. And if we look at our code, we still have our player animation function running every frame. So what's happening is, our attack animation plays, but immediately gets replaced by another animation. To fix this, we add a simple condition. For the idle animations, we check if attack IP is false. So while attack IP is true, the idle animations won't play. And we apply this condition to all directions. And now, our attack animation can actually play properly. As you can see, we now have animations in all 4 directions. For now, this is a very simple setup. We'll improve and refine this later on, but at this stage, it works perfectly fine. Now, the enemy also needs to be able to take damage. So let's go into the enemy scene and add a new area 2D with the collision shape 2D. This will allow us to detect when the player is close enough to deal damage. We'll call this player attack range. Now, let's jump into the script and connect the signals. As before, we check if the body is actually the player. When the player enters this area, we set player attack range to true, and when they leave, we set it back to false. Next, we create a function called deal with damage. Here, we check our global variable to see if the player is currently attacking, but that's not enough. The player also needs to be inside the attack range. So we require two conditions. The player is attacking and the player is in range. Of course, our enemy also needs health. And we add one more check, whether the enemy can actually take damage. This will be controlled over time using a timer. Now, if all conditions are met, we simply reduce the enemy's health. With this value, the enemy can take about 3 hits. For debugging, we can print the health value after each hit. Don't forget, this function needs to be called inside physics process. Let's test it. And, as you can see, we're not quite done yet. The enemy is taking damage, but it's happening every single frame, so the damage is way too high. This happens because we haven't limited it over time yet. Right now, it's basically 1 hit per frame. We already have the can take damage variable, but now we need to use it properly. After each hit, we set it to false. This blocks further damage until we allow it again. To reset it, we add a timer. We set it to 0.8 seconds, matching our attack animation. When the timer finishes, we set can take damage back to true, so the enemy can only take damage every 0.8 seconds. Just like with the player, if health reaches 0, we call queue free, and the enemy is gone. Don't forget to start the timer after each hit. And stop it again after the cooldown. Now let's test the final version. And as you can see in the output, the enemy takes 35 damage per hit. After a few hits, it disappears from the game. And that's it, our basic combat system is now working. One last thing we'll add in this episode is automatic health regeneration. So let's go back to our player. First, I'll quickly collapse the functions we don't need right now. Now we create a new timer. And connect its timeout signal. Here's a useful feature. We can enable auto start on the timer. That means we don't need to trigger it manually, it starts automatically. Let's set it to 5 seconds. So every 5 seconds we receive this signal. Now we add a bit of logic. If the player's health is below 100, we restore some health every time the timer fires. We also add 2 safety checks. If health goes above 100, we clamp it back to 100. And if it drops to 0, it should stay at 0. So the player doesn't regenerate after death. Let's make it a bit more noticeable and heal 15 points instead of 5. Now let's test it. After defeating the enemy, you can see the health slowly regenerating. A very simple but effective way to implement regeneration. And with that, our enemy is already feeling much more alive. We added idle and chase behavior, set up damage for both sides, and gave the combat a proper health display, so the project is already starting to feel much more like a real game. In the next episode, we will keep building on that and take the next step forward. If you want to continue the journey, I will see you in episode 4, and if you have questions, ideas, or topics you would like to see later in the series, let me know in the comments. Thanks for watching, and see you in the next one.